Hello, welcome back. We're covering the concept of simplifying these rational expressions. Now that we have the groundwork laid in the last lesson, we're going to go ahead and tackle some more complicated problems here. And I will give you a preview. We're going to be using what we call the difference of two squares quite a bit, so we'll probably have to review that along the way as well. So for our first problem, what if we have the expression that looks like this? R squared minus 5r plus 4 multiplied by r minus 4 to the negative 2 power. Now the first thing you look at is you say, well, I see that this is a polynomial and I see this term, but it doesn't look like a rational expression, because a rational expression means polynomial on the top of a fraction, some kind of polynomial also on the bottom of the fraction. But I don't see a fraction there, so why is this even a rational expression? But then you remember negative exponents can always be written by taking this thing and moving it downstairs. So you can write this as this term multiplied by 1 over r minus 4 to the second power. Or you can think about it as I taught you in that last few lessons when we talked about negative exponents. You can think of this whole thing here being divided by 1, like a giant fraction bar divided by 1. So that means I can take this and move it downstairs and make him a positive exponent. So what you'll be left with on the top is r squared minus 5r plus 4. And in the bottom, you will have r minus 4, but you have to make it a positive power. So I grab it, I pull it downstairs. Same exact thing as taking this and multiplying by 1 over that. When you do the multiplication, you'll get this. All right. Now, in order to cancel anything, I have to factor. So in the top, what I'll do is I'll try to factor this trinomial as best I can. I see I have an r squared, so that's going to be r times r. I see that I have a 4. That can be 2 times 2. It could be 1 times 4. You go through the combinations of those, and when we learn how to do that with factoring, what you'll find is that 1 times 4 works. I'm trying to get a positive 4, so it has to be either positive positive or negative negative. And the only way it works is if I have negative negative. So you should stop and check yourself. R times r is r squared. This times this gives me positive 4. This times this gives me negative r. This times this gives me negative 4r. When I add them together, I get the negative 5r. So that's the correct factorization. On the bottom, this quantity is squared, so I'll write that as r minus 4 times r minus 4. Now you can see right away that I have a common term r minus 4 in the top and in the bottom, so I can kind of strike through that and basically just write the final answer as r minus 1, r minus 4. There's nothing else I can do. I can't factor, I can't manipulate it any way to cancel anything, so this is now the final answer. And even though it doesn't look like it, this expression is exactly the same as the original one we have here. They look different, but it is exactly the same. All right, next problem. It's kind of interesting. What if you have x squared plus 2x minus 8, and on the bottom of the fraction you have 2 minus x multiplied by 4 plus x. So you might look at this and say, well, wait a minute, is this a rational expression? I thought that was supposed to be polynomial divided by polynomial. This doesn't look like a polynomial by a single polynomial. But when you think about it, if I multiply all this out, first, inside, outside, last, collect all the terms and arrange it, it's going to be a polynomial, because anytime you multiply two binomials together, you're going to have like the x squared term, you'll have the x term, you'll have the constant term, you'll be able to arrange it. So even though it doesn't look like a single polynomial, if I were to multiply this out, it would be. So this still counts as a rational expression. All right, so what I'm going to do to cancel is try to factor the top. I know I have the x squared, so the leading terms will be x and x. For the 8, of course, I could